Hello, everyone, and welcome to this Tomorrow's Talent Series Q&A. My name is Jana Toomey, and I'm with Michigan Tech. Tomorrow's Talent Series is all about showcasing in-demand careers through job shadowing videos, Q&A sessions, and curriculum resources. Today, we have some very special guests from Precision Edge Surgical Products. We have Sam Campbell, who is a CNC programmer, Todd Grove, who works in operations, and Jan Fitz in human resources. Hi, everybody. How are you?
Great. Good, how are you?
Hello.
Good. Thank you guys so much for being here today.
Thank you for having us.
So for those of you watching, if you haven't had the opportunity yet to check out the CNC program or video, make sure you head on over to the Tomorrow's Talent Series website. If you have any questions for any of our panelists today, make sure you utilize that Q&A feature down at the bottom of your screen. And with that, let's hop into some questions. So Sam, can you tell us a little bit about your company and the products that you make?
Sure. Precision Edge is a manufacturing company that focuses mostly on tools used in orthopedic surgeries. We work mainly with stainless steel, and we mostly make drills, although we do have a very wide product range. So think of like the drills you'd use for like drilling a hole in drywall, except we're doing it with bone.
Okay. And kind of very simply, what does your job as a CNC programmer entail?
So I have a really hard time like making this into a small package, but simply as I can say it, a CNC programmer is basically a person who controls the way a CNC makes a part. So that means that my job entails reading a print, determining how to make the part, and then creating all of the materials needed to do so, which is from the program to the actual instructions to the operator to the tooling.
And how did you get into your current role?
Mostly on accident. So I was in between semesters of college and I really needed a job. I think we can all relate to that. And Precision Edge was hiring, so I was like, why not? Let's try manufacturing. I've never really worked in a shop that made tools, so that's cool. And then I found out that I liked it way more than I liked school, especially because I have ADHD. So like being able to put my hands on stuff was so much better than bookwork. Precision Edge sponsors a journeyman machinist apprenticeship, which is actually a federal Department of Labor certification. And it's a pretty competitive program here. Once I got accepted to that, I dropped out of college and was like, this is my career.
So you did an apprenticeship. Is that pretty typical for the type of training or education that's required for this position?
It can be. I wouldn't say anything is really typical when it comes to becoming a programmer. There are so many different facets of knowledge that you need. You can't really say there's only one way to get there, but it is very helpful.
Do you do any sort of like continuing education classes, or is most of your learning on the job?
Most of my learning is on the job, although I am encouraged to do continuing education, especially if it's something that's going to really benefit the company. I'm never really told no.
That's great. So what are some of your favorite parts of your job?
Oh my gosh, I love like almost everything about my job. I'm probably the only programmer you're going to hear say that I like paperwork. Pretty much everybody else hates paperwork, but I really love it all. But I think my favorite part is being able to relate what the machine is doing to the operator and being kind of that bridge between the two.
So when you're creating a new program, is there like a specific language for the machines to understand, kind of how we hear about, typical software computer programmers write in?
I think if you asked a typical software programmer, they would probably say something really similar to what I'm about to say, but the answer is that is not an easy question.
Okay.
For example, like we have 20 different roll-o-matics, which are the CNC grinders you see in the video, and they use a GUI, a graphical user interface, that I can use to program those machines and not have to write quite as much code. However, the machines still run off that code, so I can do that. But then if you get into like our laser etchers, I don't get to see the code at all on those, so I have to work with just that GUI. But then you get to our lathes, and if See, the list goes on and on. Each machine is different, and it really depends on how the machine builder decided they wanted us to be able to program it.
Wow, that is so interesting. I had no idea that it varied so much from machine to machine.
Yes. Yeah, manufacturer to manufacturer is much different. So you'll see a lot of us, like I've got a team of, how many people are in our team? 4 programmers, 5 programmers? We have 5 different programmers and we all specialize. So like I'm doing grinding, but I also do etching. We got guys that are doing lathes, mills. So each machine has a different programmer that's, you know, the subject matter expert.
Got it. Okay, well, I'm pretty sure this next question is going to be a bit more complicated too, but how long does it usually take to develop and write a new program?
I don't think that's quite as complicated, actually. If my engineering team has done their job right and they give me a Christmas present package of everything I need, I can have something done in less than a day. But a lot of times we are consulted at the beginning prototype phases. So we have other companies that come to us and ask for like, hey, this is what we want. How do you think we're going to best be able to get that? And so they'll involve me. And so that process can take months.
So in the video, you mentioned many different variables that go into deciding how you write a program and the tooling that you'll use. Can you talk a little bit about some of these variables, such as the shape of the item and the material it's made from, and how you navigate those challenges?
This is one I definitely had to write down because there are so many variables. So we mainly deal with cylindrical things like drills, reamers, stuff like that. And they range from, you know, this big to seriously this big. And you don't want to think about that too hard because they're being used in the human body. But anyway, so if it's not a standard part, we have to consider like, how are we going to hold on to it? Because sometimes they can be weird shapes. And you have to get that in that same CNC that works on all these other parts. So you have to think about fixturing. Can the machine even perform that operation, or are we going to have to try it on a different machine and try something new? I mean, you wouldn't really think that that would be such a big deal, but we are dealing with really, really tight tolerances, like less than 0.001 of an inch or 0.025 millimeters. So you have to be very precise with your fixturing. There's also material differences. We deal mostly with stainless steel, and that is, if you ask a machinist, that's one of the harder to machine. Well, stainless steel is a really broad term, first of all, but we deal with all of them. So each different one has different settings I'm going to need to use to machine it the best way. If you do it wrong, not only are you probably going to get a bad part, but you can actually get something that is not going to function correctly. Like you can work harden things, or, you know, there are so many variables.
So in the future, what kind of roles could you move into, or new responsibilities could you take on from your current position?
I like to think the sky is the limit, but I'm going to let my boss answer that question.
She's right, though. I mean, if you think about in the short period of time that Sam has been in the field, in terms of going from a general labor position on day one to now being in one of our highest level programmer positions, there's really no limit. So as long as she continues to want to progress and work hard and maintain a willingness to learn and a positive attitude, there is no limit. She's right.
The thing is, our field is totally changing all of the time. Well, it seems like to me. So I am a programmer right now, but I mean, what is a programmer even going to entail in 5 years? Like, it's constantly changing.
I'm glad that you brought up that change. So can you talk a little bit more about how your job has changed since you first started, and where you see the future of this field going?
Yeah. So if I started back when I was a general laborer, my job has changed a lot since then. But if we just focus on programming, I have seen it start where we were using older technology, was less computer-based and more hands-on, getting to the machine, typing things in at the machine. And now we're doing way more at our workstations, preparing for it. And really, that makes everything more efficient. So that's a great thing. not only that, but we've seen a lot of changes where our customers are requiring us to have more perfect parts. Automation is becoming a big deal in medical. So if you have a robot doing surgery, you're going to need something that's going to perform exactly the way it did the last time. So we see a lot more of that. But overall, I mean, all of those changes are really positive. I mean, who wants a surgery that's not with the highest quality tools?
Yeah, that's for sure. So I'd like to pose this next question to all three of you, if you can come on camera for it. But what is one word each of you would use to describe people in this field? And Sam, why don't you go first?
I say creative.
Good word. Jan?
You took my word.
Best word, I'm sorry.
I would say talented.
Talented.
Yeah, I would say innovation.
Awesome. Those are some pretty great words and traits for people. I think a lot of people are looking for careers that feature all of those things. So do any of you have advice for students who are interested in getting into this field?
Absolutely. Follow your dream. Ask questions. See if you can shadow or co-op while you're in high school. We are always willing to teach. Most factories like ours, 90% of the people here have on-the-job training to get them where they're at.
And there's a lot of common misconceptions when it comes to manufacturing. So if somebody's interested in maybe pursuing a career in our field or something along the line of our trade, then maybe they should ask if they could stop and visit one of our facilities and maybe do a tour and see how different it really can be than what it is that they have in their head.
Yeah, a lot of people get it in their head that it's a really dirty job, and it can be, but it doesn't have to be. And actually, we pride ourselves in keeping a very clean facility. So it's also not nearly as hush-hush as you might think. I mean, there are obviously things that we can't just go around shouting, but we are more than willing to give you the information you need to see if you're going to fit.
And we'd also encourage high school students, if they'd like to bring their parents for the tour to help make that decision.
Family is such an important influence on young lives, that's for sure. All right, well, is there anything else that you would like students to know about this field that we haven't discussed yet?
It's pretty sweet.
It's so great to see people who are really passionate about what they're doing and making such a big impact. I mean, to be able to make surgical projects or products that are then going to change lives in the future, that's really incredible.
I guess that is one thing I would like people to know. It is a very fulfilling job. Not only, because we're doing surgical products, but because you get to see something start as a raw material and then make it into something that's useful. So if you need that kind of gratification, this is the place for you.
And one more thing, back to what Jan was stating when she had said that 99% of what we have, we train on the job. And I guess the biggest thing to let people know, because I mean, it is a big step to jump into a trade that you don't know anything about, but we have a solid group of individuals that have been here from anywhere from a year to 25 years that are experts at what we do. So there's no better way to get trained than by these men and women that do it every day.
Great.
Also, girls, come hang out with me. Heck.
That's right.
Awesome, guys. Well, thank you so much for being with us today. I absolutely learned a lot about this field. I also want to say thank you to our other Tomorrow Talent Series partners, the MySTEM Network, Upper Peninsula Michigan Works, Bay College, Gogeeba Community College, and our CTE educators. All right, guys, thank you so much for spending time with us today.
Thank you.
Thank you for having us.
Have a good day.